Hi guys, today we're back with another tutorial video. So the topic for today is inverse and composite functions. So let's start with composite functions through four of these questions that are very frequently asked in a methods exam. So first question is, what is the rule of the composite function? Second question, does the function exist or is it defined? 3. What is the domain of the composite functions? 4. What is the range of this new function? So the new function is the new composite functions. So let's take an example of fx equals sine x, gx equals sine square plus 1. Okay, what if I want you to find the composite function of f g of x? So f O of g and then brackets x, that's basically means you want to have sine of this thing and then this whole thing x squared plus 1, you want to sub it into the x. So you want to write x squared plus 1 inside the brackets of sine. And so, does this function exist? So, if we want to know if this exists or not, we need to find the range of x squared plus 1 and see if this range fixed into the domain of this sign. So we know that domain of sine x is basically x included in real, right? So all real numbers. For the range of x squared plus 1, we know that x squared plus 1 is going to be a parabol. So the parabol is translated up 1 unit, which is looking like that. That is 0, 1. So basically, your range would be included in this range. So 1 to positive infinity. So let's continue. So we know that the range of x squared plus 1 is from 1 to positive infinity. The domain of sine x is every real number. So this, the range of gx is the subset of domain of fx, which means that f g o g of x is going to be defined because of these reasons. Okay. So third question. So this is 1, and this is 2, and number 3. What is the domain of the composite functions? So we have the composite function is sine of x squared plus 1. So basically now we know that for sine we can accept any value of x. There's not really any limitation. So x is still real, all real numbers. And then what is the range of this new function? So range of sine x squared plus 1. So we know that normally sine will look something like this, right? And then continue on like that, and that continue. So we know that, okay, this is 0. This is gonna be if you have sine of x, then our period is 2 pi on 1, which is 2 pi. So 2 pi here, and then we have pi on 2, right? The normal sine graph will look like this. So what if now we have sine squared plus 1? So I really recommend you guys to maybe graph this on the Desmos to see, the shape of this thing. But actually, we still can have the values here. So the values, -1 to 1. Sine will take just all the values from -1 to 1. So it doesn't matter anything inside, if it's x squared or x to the power of 3 or anything like that, it's always going to be -1 to 1, and that's the range. Okay, so we know that range will be y included in the range of -1 to 1 with a square brackets. So this is an example of inverse function exercise. So these are very frequently asked in your SACs or your exams. So we have gx equals 4x minus 3 divided by x plus 2. Our first question is find the inverse function of gx. Second question is state its domain and range. Okay, so the first thing that you want to do for inverse function is you want to switch the x and the y. So first off, you want to write x swap with y. So that's the swap symbol. And all you want to do is instead of using this as x, you want to sub the y in and you want to make it equals to x. So x equals to 4y minus 3 divided by y plus 2. Okay, so how do you solve for y in this situation? So all we want to do is, you see here 4y, and you see here there is 1y. So we want these two to cancel out. So how do you cancel out? So you want to make y plus 2 on the top. So 4y plus 2, so that the y plus 2 and the y plus 2, you can cancel it out. So 4 times 2 is equals to 8. So we plus another 8. We need to subtract the 8 and then minus 3. You bring it down here. Okay. Then all of this divide by y plus 2. Then this one will cancel out. So y plus 2 will cancel out with y plus 2. So basically, you want to rewrite that into this y plus 2 minus 11 divided by y plus 2. So these going to be 4, right? 4 minus 11 on y plus 2, all right? So all we want to do next is we want to solve for this y. So we want to put the number 4 onto the left first. So x minus 4 equals to negative 11 over y plus 2. And the next step is you want to swap these ones. So y plus 2 equals to negative 11 over x minus 4. So then you can see here, this is negative 11. This is x minus 4. To get rid of that negative sign, we can do something like this. So 11 over 4 minus x. So that basically you times everything by negative 1. So that will change. So times the top by negative 1 and times the bottom by negative 1. All right. So that makes you this. And then you can solve for y easily, which is 11 over 4 minus x minus 2. So that is your inverse function. So we have to write g to the power of negative 1, which is g inverse of x equals to 11 over 4 minus x minus 2. All right. Okay, let's move on to question B. The domain of g negative 1 x is actually the range of gx. The range of g dash negative 1, which is g inverse, is going to be the domain of gx. So it's switch. All right. So we can easily find, I mean, if you already solve it from here to here, you can already solve it from looking at this equation, or you can solve for the domain of and the range of this original equation, and then swap it back to the domain and range of the new equation that you obtained here. So let me go with the second method, which is just only looking at this equation. So you can see here 4 minus x on the bottom. So you have a over b, then b can't be 0. So you can't divide anything by 0, right? So it's basically just domain is 4 minus x can't be 0, and then x can't be 4, because obviously you don't want to divide anything by 0. And the range is actually because this can't be 0. So the whole thing can't be 0 minus 2, which means that chi inverse can't be -2. So the range is just y not equals to -2. Or you can write it in other, interval notation. That is still fine. So y is included in negative infinity to -2. So not included with the circle brackets, and -2 to positive infinity. Yeah. And that is the end of our lesson today for inverse and composite functions. So if you want to see all the lessons of mine, just click into the YouTube channel of mine and search for whatever videos that you want to find. And also follow my Instagram, follow all the coursework that I have in my bio.